We're going to look at two methods of solving systems of equations algebraically. It's going to be the substitution method and elimination method. So in this video we're going to go over the substitution method. So up at the top here I have some steps that we can follow. What might be best is to read through the steps as we go through an example, so it'll make more sense. So the first thing that we want to do is solve for one variable, and it can be either variable, either equation. So what I mean about that is when we have these two linear equations, well, you have y and x showing up in both equations. So just choose one of the equations. It doesn't matter which one. Choose one of the variables, y or x. It doesn't matter which one. So you have a lot of options there. I'll give you some hints in terms of which one to choose. So looking for a variable that has a coefficient of 1 is really nice because then you don't have to divide by anything and you kind of avoid fractions. So when we go through these examples, I'll kind of give you my hint of how I choose what to solve for. So for this first example, actually we have two options. Actually we have three options really. We have three variables that have a coefficient of 1, so those are all really nice to solve for. I'm actually not going to use x because the y's are already solved for, which is even better. So really I could just choose either of these. I'm going to go ahead and use the y equals x plus 1. So I'm going to just write that off to the side here as the equation I'm going to use. So sometimes what we'll have to do is do a little bit of solving to get our variable on one side of the equation. It's just in this case it's already done. So that takes care of step 1. Step 2, substitute the value for the variable into the other equation. Now this is really important because if you substitute into the same equation, you're going to end up with a true state. It's going to make it look like you have infinitely many solutions when you don't. So what this means is that I chose from this top equation here. And what I found is that if I have y can be replaced by this expression x plus 1. So what I'm going to do is use my second equation, this y equals 2x minus 1, but instead of writing that out, where I have y, I'm going to replace it with this expression of x plus 1 because those are interchangeable with each other. So I'm going to take my other equation and substitute. So what this is going to look like is I'll have x plus 1 on the left-hand side of the equation equals 2x minus 1. So this is what step 2 is talking about. Substitute the value, so the x plus 1, for the variable into the other equation. So we started by using that y equals x plus 1, so we're using that second equation. And now that we're here, we're going to solve, because all we have are x's, so we can just solve for x. So I'm going to subtract x from both sides. Then I'll add 1 to both sides. So x is 2. So what we just found is our x coordinate. So I know part of the solution. Then we're in step 4, find the other variable by back substituting into the original equation, or really either equation. What this means is I now know that x is equal to 2, so to solve for y, what I can do is either plug in 2 into the first equation, or plug in 2 to the second equation. It doesn't matter which one at this point. I'm just going to go ahead and use the original. So I'm going to take this, x equals 2, and go to my y equals x plus 1. But instead of writing x, I'm going to plug in that value of 2 that we found. So this is showing me that y is equal to 3. So now we have our complete coordinate. So I would say the solution is 2, 3. And then what we could do is check our answer. You can check algebraically or by graphing on the calculator. But let's look at checking algebraically, which would be plugging the point into both equations. So y equals x plus 1. So we should see, does 3 equal 2 plus 1? It sure does, so that works out. And then our second equation with y equals 2x minus 1, so 3 equals 2 times x, which is 2, minus 1, and are those equal? Well, 3 equals 4 minus 1. Yep, that works out too. So, let's look at a few more examples, because it just kind of gets getting into the routine of it to be comfortable with the substitution method. Alright, in this example, so we don't have a variable solved for already, so this is a case where I'm going to go looking for a variable that has a coefficient of 1, so I can kind of avoid fractions. So, I'm going to use x that has a coefficient of 1, so that's going to be easy to solve for. So I'm going to do is this side work. I'm going to take that x minus 2y equals 2 and solve for x. So I'm going to add 2y to both sides of the equation. So that's a 2 plus 2y. So now what I have is this relationship that x is the same thing as 2 plus 2y. So what I want to do is take this expression that I just solved for, this 2 plus 2y, and plug it into the other equation. So I use that first equation, so when I substitute, I have to put it into the other equation. So what I'm going to do is see where I have x show up. So I have that 3 times x, but instead of writing x, I'm going to substitute in this 2 plus 2y. So I'm going to have 3 times, and use parentheses, 2 plus 2y plus 2y equals negative 2. And now we're just going to solve. So I'm going to simplify by distributing the 3. So that's a 6 plus 6y plus 2y equals negative 2. Add the 6y and 2y together, so that would be an 8y. Subtract 6 from both sides to get negative 8. Divide by 8 for a negative 1. And we just found our y-coordinate. But now we need our x-coordinate, so it's going to move up here. So what I can do is take that value for y and either plug it in to the first equation or the second equation. Doesn't matter which one. I'll go ahead and use the first equation. X minus 2 times negative 1 equals 2. Now I can solve for x. So negative 2 times negative 1 is a positive 2. I'm going to subtract 2 from both sides of the equation, and that's going to leave me with x equals 0. So the solution is x is 0, y negative 1. And then we could check our answer by plugging in the values. Or like I was saying before, where we practiced solving these graphically, we can do that. We could go to our graphing calculator and just plug in x minus 2y equals 2. And then our second equation, 3x plus 2y equals negative 2. And then where do they intersect? I'm just going to click, and there's our 0, negative 1. So you can use that to check your answer as well. Alright, our next example here, so looking for a variable to solve for. Well, x is already all alone on one side of the equation, so I want to use that. Make it nice and easy. Negative 2y plus 5. And with that, now I have what I can use for substitution. So I know that x is the same thing as negative 2y plus 5. And with that, I'm going to substitute it into the first equation. Again, sorry, I just keep emphasizing this because it's the most common mistake to make with this section. It's that we already used that bottom equation, so now we need to focus on that other equation when making this substitution. The idea being I don't really want to recycle it between the same equation back and forth because that's where things start canceling out. So, we want to use both equations. So I'm going to have 5 times, and then in parentheses, negative 2y plus 5 plus 4y equals 1. So distributing the 5 in, that'll be a negative 10y plus 25. plus 4y equals 1. Negative 10y plus 4y will be a negative 6y. And then plus 25 equals 1. Subtract 25 from both sides, and that would be a negative 24. Divide by negative 6, I'll leave us with a positive 4. Now I'm going to go find x by taking that y equals 4 and plugging it into one of the equations. I'm going to go ahead and use the second equation. I mean, either one is totally fine. Negative 2 times 4 plus 5. And that'll be a negative 8 plus 5. So x is negative 3. So we have the solution is the coordinate negative 3, positive 4. And then you can use whichever method you like for checking your answer to make sure you have it right. Alright, our last one here has a little twist to it with fractions, but with these systems of equations, there's a really nice trick for getting rid of fractions. Basically, with linear equations, you can multiply by any number as long as you multiply everything in that equation. Meaning, I'm going to delete this, but if I have this x plus y equals 1, if I have the equation 2x plus 2y equals 2, those are the same exact equation. Those graph the same line. Meaning, if I took that top equation there and just multiplied everything by 2, 2 times 1, we get the same equation. Same thing if I multiply by 3, 4, negative 5, pi. We could choose any number. As long as you multiply everything by that number, the line stays the same. And that's the important part to it, is that the line is still that line. It doesn't change any characteristics. It just kind of changes appearance, is the idea. So, with that idea, it makes it really nice for getting rid of fractions, because what I can use is the least common denominator. So, this wouldn't break any rules if I went through and said, I'm going to multiply this by 3, this by 3, and this by 3. So as long as I multiply every single term by 3, I haven't broken any rules. And I chose 3 because that's the least common denominator. So what this will do is my system of equations will change a little bit, or at least it'll look like it changed. So the 3's will cancel out, 3's cancel out, and I have a 3 times 0. So this is going to be x plus, and then 1y equals 0. And those equations are exactly the same. So my line itself, in terms of graphing, hasn't changed at all. And then I still have my x minus y equals 14. But by getting rid of those fractions at the beginning, it'll just make it a lot easier to work with. Alright, I need to choose a variable to solve for, and what can help is looking for one that has a coefficient of positive 1. So really there's 3 options. I could use any of those 3. Let's go for x. That one. No real particular reason why I chose that one over others. So what I'm going to do is take that x plus y equals 0 and then solve for x. So subtract y from both sides. And I can see now that x is the same thing as negative y. So what I'm going to do is substitute into the other equation. So I used the top equation already, and now I'm going to substitute into the second equation. So where I have x, I'm going to substitute negative y, and then I have a minus y equals 14, which is a negative 2y equals 14, and then divide by negative 2 to get negative 7. And we just need to find x. I can substitute into either equation. Let's go for the top equation. So I'm going to have x plus a negative 7 equals 0, which is just x minus 7 equals 0, add 7 to both sides, so we'll get a positive 7. So the solution is 7, negative 7. What I'm going to do is show you this on the graphing calculator real quick. And when I go to check answers, I always use the original form, if it's possible to, that's printed on the paper, just in case I made any mistakes moving to this kind of new format of the question. So I'm going to go back and use this original form. So I'm going to do fractions and all. So one equation was 1/3 x minus 1/3 y, plus 1/3 y equals 0 over, or not over, but our second equation was x minus y equals 14. And then I can see my intersection point all the way down here, and there's my 7, negative 7. So I can have comfort in that I handled the fractions correctly, it is substitution method correctly, it all worked out. Alright, that's our substitution method for solving systems of equations.